Hello everyone. In this demo video, we will learn how to integrate the useInc library into our React front-end application and interact with the proof of existence smart contract. Let's open SES docs at doc.ses.network and navigate to Developer Smart Contract. Build a proof of existence DApp. First, let's understand how the proof of existence DApp works. The proof of existence DApp can be used to demonstrate ownership of a particular file, as well as to verify that the file content has remained unchanged since it was published on the blockchain. Consider a scenario where a user needs to prove that the content of the business contract that was created using a smart contract has not been altered since its original publication. The way it works is by creating a unique cryptographic fingerprint or a hash of the data. This hash is then timestamped and recorded on a blockchain. The timestamp and the blockchain record provide evidence that the data existed in a particular state at a specific point in time. With that said, let's deploy our proof of existence smart contract. To get started, let's open the SES project page on GitHub, clone the SES examples repository, then navigate SES example inc POE, and let's build and deploy the smart contract. So in the contract, we have owned files, has claimed, claim, and forfeit functions. Has claim function checks if the file has already been claimed. Owned file function returns the file hashes that a user owns. The claim function can be called to claim a file by passing the file hash. It checks if the file hash has already been claimed by someone or if not. If not, then the file hash is assigned to the caller of the function. Last, we have the forfeit function, which forfeits the owner. Now let's open up the SES examples directory in VS Code. The front-end code that we will be using is under the front-end directory, and we will find our proof of existence inc code inside the source directory with the file name proofofexistenceinc.js. So before we get started with building the front end, we have to download some prerequisites and update some parts of the code. First of all, if you don't have Node.js installed, you can install it by following the instructions from the nodejs.org website. Next, we need to install Yarn. To install Yarn, simply execute npm install-g yarn. Now we can execute yarn install from the SES examples frontend directory to download all the required dependencies for our front end. So we have got all our dependencies downloaded. Now we need to make some changes to the code base. First, let's open the app.js and comment out of proof of existence with Solidity code, line numbers 16 and 90. Click on the line and press Ctrl/Command +/ to comment out the line, and then let's save the file. Next, let's go to the proof of existence inc.js file. Here we need to update the contract address. This can be found on the Contracts UI web page. Select the POE contract, and on top you will find the contract's address, and click on it to copy the address and update it in our code at line number 47. Next, verify that the metadata points to your contract.json file. The POE Inc.'s contract.json file currently points to the SES Inc. directory, so let's verify if the file is there or not. As you can see, the .json file is in the Inc. directory. If you don't have the file, please see the previous steps to build the POE smart contract and deploy it on SES. The last thing we need to update is the RPC WebSocket address. Since we have deployed our smart contract on the SES local network, we will update the WebSocket URL with our local URL. Navigate to src config directory, open development.json, and update the URL. By default, it is already set to the local instance of our SES node. Now we are ready to start our front end. Execute yarn start to start the front end. If everything is configured properly, you will see that the front end code has started locally on port 3000. Let's get a high-level understanding of the front end code. From the main functions return code, we have the account selector, node info, metadata, balances, and other components. If we see it in our browser, these are the top right corner and you will see the account selector component. Then on the left, there is the node info component. And next to that is the metadata component, and so on. Our proof of existence Inc. contract is at the bottom, which is the same as in our code. Let's interact with the smart contract by first selecting the Polkadot.js wallet. Then select the appropriate account from which you would like to interact with the contract. And finally, select the file that you would like to claim and click on Claim File. Enter your account password and submit the transaction. Once the transaction is stored on blockchain, we will get a hash of our file returned from this function. We can verify the claimed file from the contract's UI by calling the ownFiles function. Now let's understand the proof of existence code. Open up proofofexistence.js file at the bottom, and we have the use Inc. provider, which this hook provides Inc. contract connection information to its children components. A config object is passed in with the same name, and some chain information as well, like the ID, name, and RPC address with the use Inc. provider. We can make Inc. API calls within the proof of existence Inc. contract components. Now let's look at the proof of existence Inc. functions. The useSyncathon function provides access to various functionalities related to interacting with Inc. smart contracts. It typically returns an object containing essential information like the connected API, the active account, and other utilities for managing blockchain interactions. UseBalance returns the balance of the specified account address on the connected blockchain. UseRegistered contract is used to fetch and interact with the specific registered contract on the blockchain. We pass the contracted to this hook, and it returns an object containing the contract instance and related information. Next, we have the compute file hash lambda function that computes the hash digest of the given file. The file reader function reads the uploaded file. This function is available in the modern browser after the file is uploaded. The function then extracts the first 64 kilobytes of the data and uses the Blake2 cryptographic function to calculate the hash. This function is provided by Polkadot util crypto library. Then we have a few helper components like the connect wallet button. It connects the wallet and the wallet switcher that is displayed on the UI. So congratulations! Now you know the basic understanding of the Use Inc. library and how to use it in your app. We welcome you to start deploying exciting applications on CES.